So in this video we start a new chapter, chapter 9, and the first section of chapter 9 is called Trigonometric Identities. An identity is an equation that is true for all values of the variable or variables for which all expressions involved are defined. And here are some identities, or here's an example of an identity that's not from trigonometry, and you've probably seen it before. X plus 3 in parentheses squared equals x squared plus 6x plus 9. I can plug any number in for x on both sides of this equation, of course the same number for all values of x, and it will always come out to be true. Every single value of x satisfies this equation because x plus 3 squared is always equal to x squared plus 6x plus 9. So that's an example of an identity. But if I write the equation x plus 3 in parentheses squared equals x squared plus 9, that is not an identity. For most values of x, when I plug in, I will not get both sides equal to 0. There may be some values of x that make both sides equal to 0. You might think about whether you could even find a value of x that would work here. Think about that for a moment, like maybe x equals 0 would make both sides equal. But most values of x that you would plug in would not make both sides equal. And so that second example is not an identity. Now we're going to focus, of course, we're focusing on trigonometry. So let's start talking about some trigonometric identities. One point I want to make before we do any problems is there are certain basic trig identities that you absolutely have to memorize, like tan x is sine over cosine, cotangent is cosine over sine, secant is 1 over cosine, cosecant is 1 over sine. And then in my mind there are related trig identities that I don't necessarily have memorized all the time, but I can quickly verify them or quickly convince myself that they're true. So I'm just going to give you a few examples here. For instance, if I say cotan x is equal to 1 over tan x, that's actually true for all values of x where both sides are defined. And now if you're not certain about that, see, I would ask myself, well, 1 over tan x is 1 over sine x over cosine x, which is 1 divided by sine x over cosine x, which is 1 times cosine x over sine x. But that's cosine x over sine x, and that's cotangent x. So it doesn't take me long to convince myself that, oh yeah, that's got to be true. In fact, you should probably know that cotangent and tangent are reciprocals of each other. Another example might be 1 over secant x equals cosine x. When both sides are defined, that's always going to be true for any value of x. Now we're used to saying secant is 1 over cosine, but that's related to this relationship that 1 over secant would be cosine, at least when 1 over secant is defined. Another couple of trig identities that we should know is the fact that sine of minus x is always equal to minus sine x, and cosine of minus x is always equal to cosine of x without any minus sign written. Now, again, those are basic fundamental identities, but we can also figure out, for instance, tan of minus x. Now, I know tan of minus x is going to equal minus tan of x. And I might have to convince myself, or I might have to work through the details, tangent of minus x. If I don't recall the right-hand side, I would say, well, okay, that's sine of minus x over cosine of minus x. The identities on the left-hand side, you've got to have drilled into your minds, right? So that I could take the right-hand side here and say, okay, sine of minus x is minus sine x, cosine of minus x is cosine x. So I have minus sine x over cosine x, which is minus tan x. Sure enough, that equation on the right-hand side is an identity. Similarly, secant of minus x equals secant of x without a minus sign at all. That's related to the cosine relationship on the left-hand side. Now, we've also talked about what I call the most famous trig identity of all, the fact that sine squared x plus cosine squared x equals 1. And now this identity has a lot of related identities. And sometimes we get a new identity just by rearranging terms or taking terms to the other side. So for instance, just from sine squared plus cosine squared x equals 1, I can say sine squared x is equal to 1 minus cosine squared x if I subtract cosine squared from both sides of this identity on the left. So you kind of want to learn to recognize that sine squared equals 1 minus cosine squared is really just a form of this identity on the left. And so when you see it, wherever you see sine squared, it can be replaced with 1 minus cosine squared. And the reverse, if you see 1 minus cosine squared, you can replace it with sine squared. We also looked at, now I'm just going to use a shorthand here and write sine squared plus cosine squared equals 1. Remember how we talked about how you could divide through by sine squared? I think we went through this calculation while we were still in class. And we can obtain a related identity to this basic Pythagorean identity by, when we divide by sine squared, we get 1 plus cosine squared over sine squared is cotangent squared x equals 1 over sine squared is cosecant squared x. So 1 plus cotangent squared x equals cosecant squared x. And likewise, if you take the identity that I'm pointing at right here on the left and divide by cosine squared on both sides, you obtain another identity, tangent squared x plus 1 equals secant squared. I don't have these necessarily memorized all the time or right at my fingertips, but I can obtain them when I need them from the more basic identity on the left. So basic trig identities you absolutely have to have memorized, but realize there's a whole wealth of related trig identities. Don't memorize them totally independently of the basic ones we know. Just learn to understand how they're related to each other. Okay, so let's go ahead and start doing some problems from this section. We're going to move right into some exercises from 9.1 where you'll see some problems where you're being asked to use identities to simplify an expression. It won't be always obvious where this simplification is going. You may just have to try things you know and see what happens. So for instance, here in A, I know, let's see, sine of minus x, sine of minus x. I know I can always replace that with minus sine x. Cotangent. Cotangent, I'm going to write as cosine x over sine x. And often a good strategy in these problems is to go back to sine and cosine, because if you can break it into sine and cosine pieces, often the relationship between the different parts of the expression become more clear. For instance, secant squared, secant is 1 over cosine, so secant squared is 1 over cosine x squared. And now I can do some canceling, right? A sine will cancel with a sine, a cosine will cancel with one factor of cosine, so I'm still left with a cosine here. Don't lose the minus sign out in front. I have -1 times, I still have 1 over cosine x left from my cosine x squared. So it looks like this simplifies to -1 over cosine x, which is perfectly okay with me for a final answer here. Or if you want to be a little bit fancy about it, 1 over cosine is secant, so you could write minus secant x. Either one is okay. Either one is fine for an answer. Sometimes we prefer the simpler version with cosine. Sometimes we prefer to have no fraction involved, so we, in the appearance, so we write the answer is secant. Either one is acceptable. Now here's kind of a mess of stuff here. We're dividing two fractions. 1 over sine divided by cosine squared minus 1 over sine squared. Okay, so let's see what we can say here. I have 1 over sine x. I'm dividing fractions, so I know that's times the reciprocal of the right-hand side. This sine squared x notation, I like to write that as sine x in parentheses squared. And then I got cosine squared x minus 1. Got to think about what I could do with that. Now I can cancel a factor of sine above and below. Now I see that. That's going to happen. I'm still left with one factor of sine up above. So I have sine x over cosine squared x minus 1. All right, now it seemed like I was just talking on the previous page about related identities. Is this the same thing as sine squared? So it's almost like on the side, I got to think about, okay, sine squared x plus cosine squared x equals 1. I know there's that relationship that has cosine squared and a 1 in it. But now I want to get cosine squared x minus 1. So I could leave the cosine squared where it is. I'm taking the sine to the other side because I want cosine squared to be positive and I want 1 to be negative. If I subtract 1, I see, oh, cosine squared minus 1 is actually related to minus sine squared x, right? So I can rewrite this as sine x over minus sine x squared. And I can cancel a factor of sine above and below again. And I'm going to have 1 over minus a sine x remaining. That's the same as just minus 1 over sine x. Perfectly okay answer for me. Or again, here we could write this using fancier trig function if you want. 1 over sine is cosecant. We could write minus cosecant x. Again, either one is okay. Either is okay. So we had to be careful with how we made use of what we knew about sine squared plus cosine squared x equals 1 to get a form here, cosine squared x minus 1, that we could rewrite using another trig function. Okay, one more problem I'd like to work through on this video segment. And I'm using instructions from the textbook here. There are some homework problems where they use, I think they use these words exactly. Simplify by writing the simplified form in terms of the second expression. This second expression business, that's the sin x. So we want an answer with sin x as the only trig function. So somehow we're going to take this big mess of stuff on the left and work on it and get it to the point where we only have sin x in here somewhere. It could occur in more than one location, but to be in terms of sin x means we don't see any of the other trig functions. All right, so what can I do here? I cannot say, sometimes students will make this kind of mistake. 1 minus cosine x equals sin x. Is that what I was saying on our first sheet of identities? There's no way. I don't want to leave this written down there too long. No way that that's true. There is a relationship between sine squared and 1 minus cosine squared, but the squares are essential there. We can't just take square roots of these terms separately. So we cannot say 1 minus cosine is sine x. That's absolutely not true. All right, so we don't have an easy way to just stick a sine x in here. What I'm going to do is I'm going to find a common denominator. And it's going to be messy because I have to take 1 minus cosine x times 1 plus cosine x is my common denominator. And then I'm going to rewrite these fractions using the common denominator. 1 over 1 minus cosine x. To get the common denominator, I have to multiply by 1 plus cosine x below. And so I have to do the same thing up above. Plus, now I'm going to take the second fraction, 1 over 1 plus cosine x, and I want to get the common denominator of 1 minus cosine x, 1 plus cosine x. So I need to multiply by 1 minus cosine x. And whatever I do below, I have to also do above. So notice that I'm working on these two fractions from the original expression. I have not changed the values. I'm just rewriting them with a common denominator. So I get 1 plus cosine x now over 1 minus cosine x, 1 plus cosine x, plus my second fraction becomes 1 minus cosine x in the numerator, because 1 minus cosine x times 1 is just itself, over 1 plus cosine x, 1 minus cosine x. So I haven't really changed the look of things now. I just have one fraction plus another. Because I have a common denominator, though, I can combine these and write these over the common denominator written just once. And in the numerator, I write 1 plus cosine x, this numerator, plus that numerator, 1 minus cosine x. So I've combined the original two fractions into a single fraction, and I can combine like terms in the numerator. 1 plus 1 is 2. Cosine x minus cosine x adds up to 0. They're gone. But I still have that 1 minus cosine x, 1 plus cosine x denominator. Well, it's maybe simpler in a way, but I'm trying to get an answer that involves just sine x. I'm going to multiply this out. This is like a FOIL multiplication problem, right? I get 1 outside plus 1 cosine x, inside minus cosine x. A negative cosine times a positive cosine is a minus cosine x squared. when I multiply out the factors of that denominator, I have a cosine x minus cosine x canceling out. I'm left with just 2 over 1 minus cosine x squared. Now I see a square of cosine involved, because remember we talked about that variation on our most famous identity, sine squared plus cosine squared is 1. And what we have here, 1 minus cosine squared, is equal to sine squared. So we can write that fraction as just 2 over sine squared. We're replacing 1 minus cosine squared with sine squared. 1 minus cosine x squared equals sine x squared. And I'm sometimes using that shorthand where I write the square between the sine and the x and don't write the parentheses, but it means the same as that. And I think this is exactly what they want us to do, because now the only trig function involved in my expression is sine x. So we'll do more of these in another video.